an in-presence conference on additive manufacturing and digital inventory in the energy sector. So again, welcome everybody. It's really a pleasure to be here today with you and with this beautiful panel and discuss about a very interesting topic. But firstly, I'd like to thank Valve Campus for hosting us today and the full conference program. Valve Campus is the Italian Association of Valve Manufacturing and is really committed to promote new technology such as additive manufacturing. Today, we are here to share ideas on technologies, on digital inventories, and the question is, will this a dream or a reality? So let's discuss all together. But before this, I'd like to introduce a little bit myself. I'm Valeria Tirelli, President and CEO of Hydro, a desktop metal company. We are specialized in hydraulics and additive manufacturing. And I'm really passionate about additive manufacturing and promoting this beautiful technology. I have a few examples to share with you of our production and the benefit of using 3D printing. This is a typical hydraulics valve. On your right, you see the 3D printed parts, and on your left, the conventional parts. The comparison is quite impressive because, as you can see, there is a 60% weight reduction, one of the benefits of additive manufacturing. But that's not all. Thanks to the design for additive, we are also able to combine multiple components into one and avoid welding or assembling and have a better performance in the final systems. This is a very good example made together with Walton, an Italian valve manufacturer, where we redesigned the bonnet, so one of the components of the valve. We also used the qualification process to be sure that everything was in line with the standards. And at the end, you see the final assembly that was tested and installed. Last example that I'd like really to share is the idea that with additive manufacturing, we are able to improve the sustainability of the systems and go further on the decarbonization plan. This is an example of a 3D printed platform, as you can see, and the life cycle assessment. So it's we performed this analysis to understand the CO2 emission, comparing the conventional manufacturing, the 3D printing, and the 3D printing using a recycled powder. As you can see, there is a really impressive CO2 emission reduction using 3D printing and recycled powder produced by Fenice, an Italian-Norwegian startup. So again, other benefits from additive manufacturing, from the design, lightweight, the possibility to qualify the parts also for critical application, and sustainability. And now I'm very happy to introduce our speakers of today and start the big discussion about additive manufacturing and digital inventory. So I let the stage to Brede, our first guest. Thank you, Brede.
Thank you very much, Valeria. Hello, everyone. My name is Brede Laerum. I work for Equinor, which is an energy company from Norway. My background is actually from operations, maintenance, and modifications in Equinor, and now I'm head of Additive Manufacturing Center of Excellence in the company globally. I have to say a couple of words about Equinor. In the middle here, you see three short terms: always safe, high value, and low carbon. And that is what we are working for every day to achieve. Safety comes first. We need to have value in what we do, but the low carbon is now a very high ambition for us. And additive manufacturing and digital inventories, that I'm going to speak about as well, has an important role in this. And as you see to the left, our net zero ambition has been set, and we have to work hard to move towards the net zero society. The other is technology excellence. So we are looking into new technologies and also innovation to achieve our goals. And that's where the collaboration with suppliers comes in. Okay, so to start with digital inventories. It started as a vision 3 years ago. We had discussions with a startup company called FieldMade, and we saw that we can't do this on our own. We need to collaborate to ensure we can find results that is applicable for our industry. So we started a joint industry project with FieldMade and Siemens and Total Energy to develop a digital inventory software platform that can be used for our industry. And then moving from vision to action, we see that actually in May this year, the product was launched. It's actually a digital supply network where all end users and suppliers are connected. That means you have free flow of data, you have better transparency, you can increase the speed at which you are working, and we want to use modern manufacturing methods to produce parts on demand, so when we need the parts, where we need the parts. And that's a completely new way of thinking. And it's quite difficult because we are used to mass production methods. But we are very confident that the benefits are very clear. And if you see the map to the right, having this digital inventory available for all of us, that means me as an end user, I can order a part from anywhere in the world. It could be from Japan, from Australia, from Silicon Valley. And then you can produce the part locally, where you need the part. We have installations in Brazil, in Canada, in Norway. So it will be very beneficial for us to have a local production. So we are looking into how we can, instead of defining different companies, we are defining different roles that you see in the network model in the middle. End user, IP owner, and the factory. And the factory IP owner could be the same company or not. It's up to us to find the model that suits our needs. But as you see to the right, the ambition is quite high. And those are my ambitions. So we have to work together in the industry. The operators, we need to work together and find out how can we succeed with this. But Facebook, when that was a new product, when you had Mark Zuckerberg and maybe a couple of others connected, it didn't have any value because there was no one there. Now, with 3 billion people on Facebook, it has a high value. We will see exactly the same here with this kind of platform. With one product available, it hasn't had a high value. But in the future, if you can say 100,000 parts, hundreds of OEMs and hundreds of factories, suddenly there is a value for us and a value for all participants in this network. So therefore, it's very important to find ways of multiplying and ensure we fill up with as high content as possible. And I know there will be a lot of challenges here. We need repeatability, we need quality control, we need everything that we are used to today. But still, we know already now that we can move from 4 or 5, 6, maybe 12 months lead time for standard equipment to less than 30 days. So this is the new standard we are looking for, 30 days lead time. And that will really be significant for our deliveries if we can have a reduced lead time like that. And we also see a very high possibility of reducing our environmental footprint, like Valeria was talking about in the beginning. And I also see an important change in the resilience, because we have had many examples of not getting the parts we need the last years. We've had COVID-19, we have the war in Ukraine, we've had problems with containers around in the world, and also a ship that blocked the Suez Canal. So we are quite vulnerable with the model that we have today. Now, with the new way of working with this digital supply network, we see that we can redirect the movement of production of parts in low-cost countries. And they were moved to low-cost countries because they required low competence and high staffing. But the modern factory looks like this. It requires high competence and low staffing. That means we are competitive in Europe. We can actually home source production to a much higher extent than what we have done earlier. The other is that, at least where I come from, Norway, most of the parts that we purchase is based on transport, import, and storage. And we can reduce that because we can produce the parts locally, on demand, and therefore we require new services, local services, and local manufacturing. And that will apply in every country where we have our activities, and that is the same for the other operators. Now, a few words about sustainability, and you have to arrest me if I'm over time.
Perfect.
Additive manufacturing and digital inventory fits perfectly into a circular model. That's why we should work very hard to achieve that. First of all, when it comes to raw material, we see already now a shortage of some materials in the world today. So if we can reduce the amount of raw materials that we use, that's a high benefit. And we know that by designing for additive manufacturing, we can reduce weight, reduce the amount of raw material we need with 60, 70, maybe 80%. So designing for additive manufacturing is going to help us when it comes to material shortage, but also around 30% of the CO2 emissions in the world comes from extracting raw materials. So if you can reduce the amount of raw materials we need, we will reduce CO2 emissions at the same time. In addition, we see that using subtractive manufacturing, you have a lot more waste than in additive manufacturing, where you add material from nothing to the final component. So there you have an additional effect in reducing the raw materials you need. And also by producing parts locally, then of course you reduce transport. When it comes to operations and maintenance, we can reduce our huge inventories, the physical inventories, by working in this way. And it's important for us now to say that, okay, this is a major transformation. And the suppliers, you will ask us, okay, how will we earn money if we're going to reduce the amount of physical parts we are going to purchase? Well, we're actually now trying to find a model to give you an income on the digital content. And that's something completely new. And we're not all there yet. It's a process that is ongoing. And I'm quite confident we will find a good solution so that you will get paid for the physical component, but you will also get paid for the digital content. Now, in addition, we have the possibility of improving function. That is, you can improve efficiency of turbines, of pumps, of motors, and therefore reduce energy consumption and CO2 emissions. And also an important thing we've seen many times is that we have lack of spare parts. Old equipment, we can't get spare parts, and we are forced to replace a whole motor or a whole pump. Now, with additive manufacturing, we can 3D print a fan if that's the part we are missing. And we have calculated that by 3D printing the fan, we have 3.8 kilograms of CO2 emissions. But by replacing the motor, we have 4.5 tons of CO2 emissions. So it's more than 1,000 times more. So why do we continue to replace more than we need? We can replace just the one part that is the problem. And finally, I heard the presentation from Luisa from Fenice today. They have a solution to recycle scrap metal directly into 3D printing powder. So thereby, we close the loop. We can use recycled material as the feedstock to the new parts that we are going to produce from the digital inventory. So if you add all these different effects, it will have a great impact for our industry to demonstrate that we can be part of the solution, not just part of the problem. So what you've seen is that additive manufacturing and 3D printing, it is a very versatile and promising technology if you put it into a larger context. And the digital inventory, the digital supply network, is a way of putting it into a larger context. But the bottom line here is that it brings a new mindset, a new way of working, and that is what we all have to work on very hard to strive to make our organization change, make our organization see the new possibilities and start exploiting them, and come to us and present, hey, we found up a new way of producing this part, or we have a much better part. So come and show it to us, and we will definitely be more interested in discussing new ways of working than what we have been before. And just finally, I would like to mention that collaboration here is key, and we are very open to do an open dialogue with the suppliers, and that's why we started the AM Energy. And Valeria is in the steering committee together with me, and the point is we need to talk together, we need to share experience, share knowledge, because it's too large job to do on our own. We have to work together to manage to lift the industry and to get the results that we want. So with that, thank you very much.
Thank you, Brede. Thank you very much. And so we can start with the first question to you. So, additive mindset. Who already knows additive manufacturing and has experience on 3D printed parts? Please, raise your hands. Okay, a good percentage. Thank you very much for your participation. So we can go further with the next speakers. So I'd like to invite Angeline Goh to stay on the stage. She is the Additive Manufacturing Technology Manager at Shell. Please, Angeline.
Thank you. Testing?
Yes.
Good. Seems to work now. So, good afternoon, everyone. I'm really excited here to be speaking to you about additive manufacturing. But before I start, I thought you could, I want to share a few things that allows you to get to know me a little better. So the career stuff you could see in LinkedIn. A little bit about myself. In 2003, I took a job in Sweden that came with a company car, but I didn't know how to drive. Then in 2006, I moved to Germany. I took on a job as a plant engineer in Schleswig-Holstein, where German is the communication language at work. I didn't speak any German. And then finally, I took a job in 2009 in Singapore as a supply chain planning operation manager. I have no supply chain experience, not training. So, I embrace change and I love challenges. And I see that all of these challenges can be overcome. What did I do? On the first one, I enrolled myself in a driving boot camp, and fortunately, I passed my driver's test on the first attempt. On the second one, I took intensive German lessons, and I also painstakingly every evening translated my work documents. But over time, I learned to speak German from listening. Actually, I speak the type of German that the locals speak, so not very good at the moment, but I certainly could express myself and I've learned all the technical words in engineering in German. And finally, I was very fortunate as a planning manager to have a team of about 7 people. And together, they had a century worth of supply chain knowledge and experience. The way I did my job was to make sure that I listen. I engage with stakeholders, understand the priorities, and I'm there to help my team unlock the blockers that they face. So, I believe that is also the challenge we face as an energy sector. The energy transition is a big challenge. We have a lot in front of us that we need to overcome. And with that same attitude and the experience, I hope that we can together also make a substantial, radical digital transformation towards the topic that I'm passionate about, digital and additive manufacturing. This is a mandatory slide, so bear with me, just on definitions on different shell entities, as well as to make sure that I inform you the slide I'm sharing, that information is a forward view. Do not make your investment decision on this. Taking it and personalizing it for myself. So as a parent, and hopefully the story relates to most of you, if not all of you. As a parent, I'm used to that once a week, once every 2 weeks, I go out and get my groceries. I buy a lot of food with a good intent to cook for my children. But what happens? Reality hits home. I have late calls. I don't actually cook as much as I would like to. Food goes to waste. The European Commission estimates that 20% of food produced are gone to waste. And globally, that figure rises to about a third. Interestingly, in Shell, we estimate that 30% of the materials we buy and keep in our inventory does not get used as well in their lifetime in the warehouse. This represents resources, energy used to produce the part which are now gone wasted. Just as food is essential for life, spare parts are essential for operation. It is important. And so stocking strategies were taken. However, I think we can do differently. So what do I do differently? Today, I typically just take a quick walk to a nearby local shop. I buy what is needed for a day or two. Food is freshly prepared. I have the agility to change my mind about the menu. I also could take a decision that I will order in for the day and not cook. And the same agility presents itself when we work with digital spare parts, where we can produce it only when we need it, and when operating conditions changes, we now right size and make the changes in the digital file before we produce. So we stay up to date that way. There was often a question that I get about Shell's journey into additive manufacturing. We have in Shell have had the privilege to already use metallic additive manufacturing for the last 10 years. The journey started actually because we in Shell has a research entity. So we currently have 2 facilities, one in Amsterdam and one in Bangalore, and between them about 15 machines. The one in Amsterdam is dedicated to research, and the printers are there to produce bespoke equipment parts, which we use our laboratory. And this is needed because we are residing next to our creative scientists who are trying to find solutions and to also conduct experiments to test their hypothesis on certain equipments which may not readily be available in the market. The facility in Bangalore is there. We have about 5 printers to support also energy transition. There, the machines are dedicated to support startups who have big ideas to contribute to sustainability, and they actually want to be able to prototype and take their business idea into actual products. So the facilities volunteered to help these startups materialize their dream. We have 3 focus areas in Shell. Spare part management is a significant one. We also do the novel design for the R&D branch within Shell. And finally, we do also support assets with visualization items that they can use for training and also for safety demonstration purposes. That was Shell's journey into additive manufacturing. My personal journey into additive manufacturing started when I was a supply chain professional in Shell. I was in the Center of Excellence, a program manager looking at how to improve supply chain challenges that we face as an industry. I became very acutely aware of the challenges that the people in the asset and the front line are facing sourcing for obsolete parts. It's very stressful and it can take months. I was also aware that traditional manufacturing, with the need to have the economy of scale, tend to centralize, and we know that that leads to significant long supply chain. We also notice that the energy usage as well as material usage is not optimized. With long supply chain, that leads to also high, long lead time for delivery, high CO2 emission related to the supply chain. We do see that on top of these supply chain challenges, materials still get stuck in the custom. I recall an incident where we were able to very quickly reverse engineer a part for a site, all in all within 2 weeks of production. And then the material was actually stuck in the airport for 4 weeks. So that lesson we took with us very early in the stage of additive manufacturing, that if we really want to use this, it has to be on demand and close to the end user. Because lead time is a key factor in deciding on a stocking strategy, it often drives the behavior of buying and keeping in a warehouse just in case. As a result, warehouses are filling up. We spend a lot of time preserving those material, and yet, technical challenges. With the warehouses, we see that there's significant wastage as well, because materials don't get used and they're written off from our books. A well-filled warehouse has also significant HSSE, so safety man-hour exposure for the people working in the warehouse. And this is a risk, and we would like to reduce it. Finally, as I just mentioned in the previous article, with physical stock, you have no agility. You are going to find that in some cases, after 9 years, either the materials is not fit or your operating conditions have changed. And unfortunately, those stocks cannot be used. So with this and the experience we gathered, we are very keen to start working towards a digital inventory. What is a digital inventory or warehouse? It is a warehouse in the cloud, and it will contain the digital data package that is necessary to recreate the part when we need it. And what we've seen and we've learned now is that it may not be one centralized global warehouse, rather an ecosystem. What we need to establish is how to connect them. The standardization that is still needed to allow this. The beauty of a digital warehouse is that you can never be out of stock or have excess stock. You also eliminate obsolescence. Things that we are dealing with today on a daily basis. We want to build a future, an asset that does not have to deal with the same problems that we face today. In Shell, additive manufacturing and digital inventory is not a technology that we develop in isolation. We see that the true beauty of this is to be able to leverage this technology alongside with other technologies that comes together to create for us what we think is the asset of the future, an autonomous, safe, efficient asset. So with this visualization, what I was hoping to portray to you is the vision that we have. The operators round is done using drones and robots. They're picking up data using machine vision and artificial intelligence to deduce and predict maintenance work that needs to be done. It triggers a prescriptive supply chain within our system autonomously. And the file, the digital passport of what is needed to produce the part, is picked up, sent to the right location closer to the end user for production. All this chain and transfer of data using blockchain. Once the product is produced using additive manufacturing or other digital manufacturing, within 2 to 4 weeks, it's delivered to the site. And the worker on site can perform the maintenance work timely, perhaps using virtual reality to do assisted maintenance. The data information we collect from their work is curated in the digital twin. So we know very well now how the asset's going to perform. This is our vision of bringing several technologies together and using it effectively. I want to showcase a story of collaboration. This is a project we did together with a valve vendor, Boniforge. In Shell, we love our valves. We use plenty of them. I think we have about 25,000 different types of valve in our system. What we experienced is when an emergency happened, we are willing to pay up to 5,000 times the original cost of the valve. But even in such circumstances where we're willing to pay because the operations is at stake, we sometimes find that the valve is still taking 6 months before it arrives to us. Imagine the exposure, the risks, and the inability to produce during that time. So what we did in one of the face-to-face meetings with the valve operators, valve manufacturers that we work with in our company, we put the question on the table: would any one of you be keen to work with us? Do you believe that an additively manufactured valve can meet or even exceed the performance of a traditional manufactured valve? Boniforge raised their hand. They gave us the permission of a 1-inch class 150 valve to produce it additively. We decomposed the valve, we printed the components, except 2, and we gave it back to the valve manufacturer to assemble it, and it was subjected to significant testing. More stringent tests than they normally do for traditional manufactured valve. The burst test was one of the last tests performed at about 150 bars, and it held with no observable deformation or any leakage. In fact, I think they were upping the pressure even further to almost double of that. And it was not the valve body that failed. So they had to stop it. This was in a way impressive in the sense that in every single aspect of the test, they, with their experience, to compare it to the way that they have been manufacturing it traditionally, concluded this valve was impressive. In Shell, we have made also effort to print parts in other areas in collaboration actually with OEMs and other independent service provider. We are quite clear to have an effective digital inventory, we need the scope, the diversity of parts. Brede has showed in the earlier slide, there is an ambition of a high number of inventory, and we need to start to work towards that. Here are some of the examples that we have printed, and many of them in service. From pump bearing housing to impellers, valves we didn't put in service yet, fork pipes, valve trims. We have also some polymer parts and water barrage seal. Shell has also this year qualified the first CE marking on a pressure vessel certified by independent third-party service provider against the DEP. Finally, a showcase that we recently concluded was a pressure-retaining low-pressure clamp, which we have now put in service for almost 3 weeks in collaboration with Teams and Valorec. So, what's next? We believe that the future is here. We know that digital inventory is already in use in other sectors, and energy is now ready to embrace it. The new future is the digital supply chain, and the new digital supply chain has challenges. In a supply chain, you plan, you make, you deliver. And in this new supply chain, we need to plan for and get ready the digital spare parts that we can use for the energy sector. We would like to be able to make it effectively, which means that some standardization around the QA/QC process has to be there. We need a simpler way in which we can order and know that we will get quality part that meet our requirement. We also believe that in the new supply chain of delivery, we're dealing with delivery of digital package of data. How do we ensure that they are secure? How do we ensure that we protect the IP of the designer behind it? These are challenges that we will face, but I'm convinced that with the like-minded people in the industry, people who will be part of their ecosystem, we can solve the problem much quicker. And this is the ambition that we have. And also, for us, the time is now to think bigger and work together. We welcome collaboration. We need collaboration. And I hope that you too would work with us, step up, and address the challenges we want to overcome. Thank you.
Thank you very much, Angeline. Very nice and interesting presentation, and thank you especially for sharing your personal history. Very, very, very nice. And now, who is ready to embrace the change in the audience? Just raise one? Only one, two, three? Oh, okay. We have to work more to convince them that it's time to change something. And another question, who is facing issue in the supply chain? Delivery time, crazy suppliers? Okay, not so many. We have to work also on this point. No, I think that at the moment it's really quite crazy. In some sector, the supply chain is really stressed and there are a lot of long delivery time. But I think we can go further and listen to the next speaker. So I'd like to invite Edwige Ravry from Total. She's the Additive Manufacturing and Digital Inventory Product Owner.
You got it.
Thank you. You're welcome.
So it's a pleasure to be here today. Valeria introduced me, so I'm going to skip over the biography to save some time. But what I really wanted to say is that I'm sure Brede likes to talk about the four of us, the four operators, as a quartet. And I'm sure you're finding that we are speaking really with one voice today. And to complement the visions that you've been presented so far, I would really like to show you just how industrial 3D printing has actually become today. This slide is my personal conservative estimate of what has been field deployed today in our industry. There is more than 1,000 low criticality parts field deployed already. If you look at the examples presented here, some fan blades for the cooling system of a gas injection system, and then you see right next to it the polymer translucent cap on a solenoid valve. Well, for example, that cap, when it fails, we are kindly invited to buy a new solenoid valve. But if we only replace the cap, we're reducing Scope 3 carbon emissions by 90%. So that is no longer an acceptable answer. If we repair instead of buying new, as shown in the refinery component below, we again reduce Scope 3 CO2 emissions by 90%. That component saved us waiting 7 months for a replacement part, and it saved the refinery 7 million euros. Some components are becoming really mature in additive manufacturing. Pump impellers and control valve trims are good examples. There's been over 100 impellers field deployed across our industry. And by talking to some companies here today, I realized that I grossly underestimated the number of control valve trims already in the field. We're probably close to 100 already. And those parts are paving the way for even more critical applications. So on the right, I'm happy to present to you what probably was our industry's first safety critical component to be field deployed. So this is a drilling accessory that was manufactured by Vallourec using the technology known as wire arc. It's almost 1.5 meters tall. This component is used after drilling when you run the casing. In case of a loss of well control, you need to be able to connect the casing with the drill pipe, and they are different diameters, different threads, so you need a crossover, which is never the same, so we need it on demand. If that component fails when it's used, it can cause severe damage and loss of life. It is subject to the API 5CT. It was qualified using a DNV standard for 3D printed equipment. Now this was a first. COVID came in the middle of it. We had to make 2 sacrificial components, 150 coupons were tested. This project took a year. But now we've been promised a 12-week delivery if we buy the same component again. And as this technology becomes more industrial, that will only reduce to maybe 3-4 weeks. And this is a nice opportunity to also show you the design benefit of additive, which we stumbled upon in this application. It was unexpected. We were really just looking to reduce lead time, to show that instead of struggling when you don't have the right forging in stock, you can print the part you need. But you see on the left, you would start from a 1-ton forging, and you would machine away half of that, because machining time costs money, so the part is more expensive if you machine away the unnecessary weight, so you leave it on. Instead, if you 3D print the part, it's adding material that costs money, and therefore, Vallourec suggested redesigning the part, and we only waste 150 kilos in the finished machining. So now, and this was a good first candidate because it's a temporary component. So although it is safety critical, it's not a permanently installed item, and that is really the next frontier that we're working towards as an industry. And now I'll show you our second safety critical component, which is soon going to be installed. And I took the opportunity to do a case study of where are we with additive manufacturing in sub-Saharan Africa. Oh, and sorry, before I say that, we reduced the carbon footprint of the component by 50% as well. So this is what's been happening in Africa with additive manufacturing. On that map, I've highlighted the countries which are producing today in exploration and production in total. And so Gabon, Congo, Angola, and Nigeria, between the 4 of them, have already 50 low criticality parts deployed, some of which had been printed in country. And recently, Angola ordered 40 composite hand wheels to be deployed on valves. So the revolution is underway. A few examples. Nigeria have ordered already 3 control valve cages from MICCI using laser powder bed fusion. But you see, we're experimenting with a broader and broader range of technologies. Up on the right-hand side, you can see an impeller that was manufactured by Sulzer using a technology called hybrid LMD, where you start with a core on the left, a machined standard core, forged, and on which you then add increments of melted powder as you go along, and then you machine what you just added. So it's a hybrid process, machine, add machine, and that allows you to let's say, get smooth surfaces on the inside before it becomes inaccessible. And so this allows you to get greater precision than with casting, which can unlock higher performance. And that component will be field deployed end of 2022. This is a first for Total using this technology. Last but not least, top left, you see our second wire arc component, which is also safety critical, as I said, subject to API 6A. It was built by Technip FMC and qualified using API 20S. And that should be field deployed a few weeks from now. And that is used for well testing, workovers, and in this particular case, as you see on the middle picture, it's used to monitor and purge annulus pressure on that well. Last but not least, we can only deliver the promises of additive manufacturing if we have machines in country in Africa. Right now, it's a blank map on the map of installed hardware. There's nothing there. And this is such an important region for us. It's 20% of our production. And most of these projects are operated. So we have direct access to these assets. And this is where our biggest inventories are. Total has 3 billion euros of inventory, and most of it is in these countries. So Angola paved the way, and they have ordered the first metal 3D printing machine in Total, which is bound metal deposition system. And so that's very exciting. And hopefully it will pave the way to greater things. Total has announced the first investment decision on a project called Tilenga in Uganda. So we're talking 300 plus wells to be drilled, a separation and treatment plant, and a pipeline to export the oil via Tanzania. These two projects that you see, Tilenga and Kingfisher, are the only major industrial endeavors in the country. So there's no industrial infrastructure. Any spare part that we order will have to arrive in Kenya and be transported overland across a border more than 1,000 kilometers. So there's a very, very strong case for in-country 3D printing. And what we are going to be doing over the next few weeks and months is to start engaging with the OEMs to whom we have awarded packages on Tilenga to screen the spare parts they recommend and try to find as many candidates we can for a given technology so that we can justify the hardware investment. But of course that means that different OEMs will have to share the same hardware. And so how do we get there? And now back to what Brede and Angeline have mentioned. We have a vision for turning our linear supply chain into a connected supply chain ecosystem. We want our parts to be stored virtually in the cloud, printed on demand by pre-qualified third parties. Today, if we order a turbine, for example, the order goes to one entity that may then have to, let's say the order trickles down 3 or 4 layers, and because of the subcomponents in the turbine. And so if one of those components break, each layer will add a markup and a lead time before we receive the part. So that's the inefficiency that we are targeting. And the other problem that we're facing is if we use a new cool technology to deliver a part, then the OEM we work with, of course, tells the world. And then when we turn around to order another part, the machine is full for the next 6 months. And so what do we do then? If we've sold the dream of short lead times to our maintenance engineers and we can't deliver on that, then that asset is burned and will not want to use 3D printing again. And so in order to tackle that challenge, Total, as Brede mentioned, has been partnering with Equinor and FieldMade, now called FieldNode, as well as Siemens. And here are the challenges that we're addressing head on. How do we select the right parts and digitize them? Because the parts are not made to be 3D printed today, those we have on the shelf. How do we qualify these parts? What are the commercial models that we need to invent that will allow us to share the value with our OEMs to make it worthwhile for you guys to engage in this? And then how do we secure the IP that is shared via this digital interface and track the transactions? How many parts were printed? Based on the prints, you compensate the IP owner for the usage of that IP. And this system, if it's going to be used, needs to be integrated with what we already have. And now I would just like to take a step back and to show how this all fits into the transformations that our companies are ongoing right now, are undergoing. Total changed names a year ago and became Total Energies. We want to be a major player in all the energies you see listed here. So the new ones for us are electricity, hydrogen, biomass, wind, and solar. We want to be in the top 5 of the renewable energy players by 2030. So this will mean a lot of solar panels and a lot of wind turbines. And of course, to complement those intermittent energy systems, we need energy storage. I'm sure you've seen that solid-state batteries are 3D printed today. We also need hydrogen as a storage vehicle. And there is research showing that 3D printed components can resist hydrogen damage in fuel cell applications better than raw materials. This will allow us to reduce the quantity of oil that we sell. We will increase gas, but for both of those, we need to sell more and more renewable forms of those fuels. So for instance, we'll be selling jet fuel made from cooking oil. We will be taking CO2 and by electroreduction, turning it into ethylene and methanol. And we are investing heavily into biogas. Today we have 7 biogas plants. We're going to be building another 20. And so we're looking at how 3D printing can make all that faster, cheaper, and better. And we have unlocked some really exciting performance improvements, but which I can't really disclose today. But even all of this will not be enough. In order to reach our net zero targets, we need to capture heat, for example. So we're looking into supercritical CO2 heat capturing systems, where 3D printing is very exciting. And same thing for carbon capture. We are investing massively in that. And it's all about the contact between complex surfaces and the CO2. So 3D printing is a very interesting avenue to explore there as well. And as a final word for me, we do have targets on scope 3 emissions, as you can see here. But today that means the CO2 emissions from the products we sell. But a year from now, I expect that line to also include the emissions from what we buy. And so we need to work with all of you to scale up the use of 3D printing and to do our part to combat climate change. Thank you very much.
Thank you very much, Edwige. And have you seen, Total has already started a big plan for 3D printing, installing also printers in Africa, in this case. And I'd like to ask you, who has a printer, a 3D printer at home or in the office, in the audience? 1, 2, 3, 4, okay, someone. Who has a paper printer at home or in the office? Just to, I think the majority. Okay, so let's think that maybe in the future, the same people that raise the hand for the paper printer will raise the hand also for a 3D printer at home. Thank you very much. And now we have our next speakers, Carlo De Bernardi, please.
Thank you.
You're welcome.
Have a presentation. Can you hear me? Yes. I don't have a presentation, nothing fancy. I didn't prepare anything for today. I'm listening, because I believe that listening is the most important thing. So my name is Carlo De Bernardi. I work for ConocoPhillips. I'm based in Houston, and my background is I'm a valve SME, but I'm also leading. Does it work? Okay. But I'm also leading a number of additive manufacturing initiatives, some jointly with these nice people and others within ConocoPhillips. My background is manufacturing, because I started here in Italy working for a valve manufacturer, and I work for an end user since 10 years now. What can I say? There are a few aspects, because today you saw the 30,000 feet approach to what is the vision, what is the future, but I believe that we need to define some base rules. Probably it is not clear today how additive manufacturing is fitting into the traditional supply chain. So I would like to send a clear message that we as operators or end users, we are not planning to become manufacturers ourselves. We are not planning to print components taking the job away from the OEMs. In order to do that, we need to be clear what is an OEM, what is an operator, and where additive manufacturing is going to fit. In my opinion, additive manufacturing should be fitting into the traditional supply chain model that we have today. It's just another way of making things. We can make metals, we can make polymers. As an end user, I do not really care about 3D printing per se. I care about 3D printing when it makes sense. I care about the final component. I use a component in its final stage and state. Probably not everybody understands that additive manufacturing is not just the printing process. So having a 3D printer doesn't really make the job itself. Everything starts with the feedstock, and we touch base on the feedstock very briefly. You have the printing process, and then you have the post-processing. In metal 3D printing, most likely you will need some heat treatment, eeping, stress relief. These operations are all integral. They are all equally important. Actually, post-processing can be even more critical and even more important than the printing process itself. So we need to figure everything out. And what is the very first place where you want to start from is standardization. When I started my journey in additive manufacturing, purely by chance, I realized that we didn't have an industry standard in the oil and gas for 3D printed components. So I started a task group that is called API 20S that I'm chairing, and now we have a document that is a qualification document. The qualification document, how many people are familiar with API 20S? More than I expected. So that is already a good sign. But API 20S is not only about printing, it's about feedstock, it's about printing, it's about post-processing, it's a qualification process of a manufacturing process. Manufacturing is broader than 3D printing. We have API 20T that is in the works. So 20T will be the equivalent of 20S for polymers. Polymers, they have a number of applications as well, and many more are in the pipeline. As of today, that is not enough, because even if with API 20S, technically you cannot really deploy 3D printed materials into any product. API 6A, and I believe that many people are familiar with API 6A, technically doesn't allow the utilization of AM materials. We are actually working to change that, but in order to change that, we need data. And these data are coming from the field trials that they were talking about. It's all about collaboration. So one big barrier that we have to take down is the one of keeping data and results for ourselves. If we do that, there is no progress. If we do that, there will never be an acceptance, for example, in NACE MRO 175, there will never be an acceptance in API 6A. There will be a bunch of opinions. There are people that they have the opinion that 3D printing is great, others the opinion that 3D printing is not good. I don't care about opinions, I care about facts and data. The data that I can share today is that 3D printing is widely deployable as a technology from a technical perspective. I'm not really worried that 3D printing is not able to achieve the same performances of forgings and castings. I'm more concerned about the competitiveness of 3D printing. 3D printing has to be competitive. In order to be competitive, like any other technology, it has to work on volumes. Today, we do not have the volumes. So you can imagine that a 3D printer itself is a very expensive machine. So you're talking about, I don't know, $2 million for an industrial type of metal 3D printer. If you're using that $2 million machine to print a tiny object alone, the cost per object is extremely high. If you're optimizing what is called the print bed, and you are embedding different objects into that 3D printer, the cost per unit is going down. And in some cases is actually even cheaper than forgings and castings. But how do we do that? We do that by combining different type of components. And again, back to the collaboration. We need to have different OEMs, even making different type of equipment available and able to share and work together with third-party providers to optimize the entire process. That way it will be economically viable, and that way the digital inventory concept will be a reality. That is it.
Thank you very much. Thank you. Thank you, Carlo. So you have listened to the 4 presentations of our additive manufacturing leaders from end users or operators. So this is their vision. Now we want to go deeper in the discussion and invite the OEM representative. And I'd like to invite Steve, first of all, because it's really important to share the discussion and to have the same vision for the future. As you have seen, they have a very big, ambitious plan, additive manufacturing, digital inventory, to create an ecosystem. So let's talk now with Steve Freitas from IMEI, the Director of Research and Development, and listen from him what are doing a valve manufacturer, an OEM.
Thank you.
Thank you.
Can you hear me okay? Not yet. There we go. So thank you for the introduction. I'll get started. So my presentation, I'll give some examples of how we actually developed the technology and put it in place from the kind of nuts and bolts side that we had to deal with. So I'm come from California. I flew in last night. I'm here, I'm awake, so thank you for hosting me. So we make at CCI a very special control valve for high pressure letdown applications. It has this internal flow passages shown in the picture, these tortuous flow passages, and it's made from stacked plates. We've been doing this for about 50 years. And the way we make these is we take plates from sheet metal and we cut passages in them by laser, by punching, or by EDM. We stack them up, we brace them together, and we put them inside valves. And the valves can be small, like a 1-inch valve, but we also make as big as a 2-meter tall to stack for inside a condenser. So all different sizes, all different shapes, all made from stacked plate in all kinds of typical valve steels like 316, 410, Inconel 718, and tungsten carbide. About 2008, I began interested in how to make our very smallest parts, our 1-inch parts, more accurate for flow control. And this was driven by a need to make better control valves for power plant industry, not oil and gas power plant industry. And my goal back then was to improve the accuracy of our small disc stacks. And like Angeline, I didn't know anything, so I started from nothing. So our process was design it, build it, test it, see what happens. And you can see from pictures, it didn't come out so good at first. At that point, it was a brand new technology, and our supplier didn't know much either. And you can see the part in the top was supposed to be a straight-up cylinder and didn't come out that way. And the part in the bottom you see that's got these flat flow paths have got like little stalactites in them, right? It's called dropout. So we did not have good results in the beginning. We did some small changes and made it work for us, but we couldn't really make it a mass-produced part. We couldn't really make it in volume. We could only apply what we found for a small number of parts each year. And we kind of stumbled along that way year after year. In 2017, we reviewed some new papers and technology on additive manufacturing, and we thought we would re-engineer the passages from scratch. So we went back to the drawing board, threw out all of our old design rules, and started from scratch in the valve designs, and came up with a new configuration which was optimized for laser powder bed fusion, and that was a huge success for us. And we've since shipped probably over 500 parts. And these are parts used in applications with 140 bar pressure drop in water, 60 bar pressure drop in steam service, and some oil and gas parts. So one of the things that we make a lot in our factory is large disc stacks in Inconel 718, primarily for high temperature applications up to 600 degrees Celsius. And you can see in the picture we have the disc stack in the back is made from the legacy process with stack plates. The one in the front is made from the laser powder bed fusion process. So we created a new design architecture for AM, which reduced the overall size of the disc stack by 25%. When you're making a big part, like Carlo pointed out, that's very important. If you can make the part smaller, it's easier to make an additive because additive costs more per pound than most legacy processes. In addition, if you make the part smaller, it's easier to handle. So the guy's got to put this thing in and out of the valve in the field. You've just made his life safer and easier to do, especially if it's installed sideways in a funny pipeline. We did validation with typical engineering tools like CFD, flow testing, and FEA, and load testing. And we've put many of these parts in the field now, and they're working successfully. And in addition, something new that's happened since January is the price of Inconel sheet has gone way, way up for us. So our operations team is saying, can we please make more big disc stacks in Inconel 718? We're printing a part right now that's 340 millimeter diameter on the ID. So it's going to be a huge part that's in production right now. Also with additive, we can be creative about the shape of the part. Our legacy parts are cylindrical parts. They fit with inside valves. I can now make parts that are maybe different shapes, three-dimensional parts. This is a part that goes inside a rotary control valve, and you can see it's got an elliptical or spherical surface. This part is pretty big. It's about 18 inches wide, 8 inches deep, 8 inches across. It fits inside the valve on the right. The valve was produced here in Piacenza. It's a 24-inch 900 class valve. So we can now make new kinds of designs with 3D printing that we couldn't do before and apply new technology and new applications. And what we've also done is taken the technology to a process called Retrofit 3D. This is a program we run which is focused on making parts very quickly for customers. In many cases, we can produce parts in 4 to 6 weeks for customers if there's no special certification requirements, if we can just install a native AM part. And we can also fit the parts in different sizes and shapes of valves. And the part on the right is interesting. The part on the right is actually a diffuser, which fits inside a valve outlet to prevent flashing and cavitation damage. So this has been a really transformative new change to our business, and we've put in place in the past year and a half. So that's a very quick summary. Hope that was okay. Thank you, everybody.
Thank you. Thank you very much, Steve. And the first question for you, so you as valve manufacturer, how was the introduction for additive? So the people, your engineer, technician, how was the reaction?
That's a really good question in two ways. There always is, and I'm sure you find this too, there's people that don't believe in it. They don't understand it, they're afraid of it. And so one thing we have to do is convince internal people in the company this is okay. And very often we find that they require a higher level of testing and review than our own customers do, because they're afraid to make a mistake and harm a customer. So one thing you'll have to do, all of you, with the technology is teach your colleagues about it and help them understand how it could be okay for their applications.
Thank you very much. Normally we have another person, but unfortunately he had some issue with the flight, so probably he will be late, so let's see if he can join at the end of our panel. So we can go further in the discussion, and to give more reality on the topics of additive manufacturing, we would like to invite the technology provider on the stage. So please, we have Paul Gatley from Destometal. We have Jens Karnapp from AOS. We have Giancarlo Scianatico Robots and Zach Walton from Velo 3D. Please, take your seat, and I think we can share the mic with them, maybe one for them. Okay, and you can share too, okay? Perfect. So, thank you very much. First of all, I'd like to ask the same question to all of you. So just introduce yourself, please, and let us know what you are doing to reply to the requirement of this beautiful panel. So how you are working to improve additive manufacturing in the energy sector and to be ready for the digital inventory. So Paul, please.
Am I on?
Yes.
Perfect. Good afternoon, everybody. Wonderful day. I'm really pleased to be here and, with this esteemed panel here. My background in is basically I'm a mechanical engineer by trade, working in tool making as my background. Moved into 3D printing about just under 20 years ago. It was a light bulb moment for me, as being a mechanical engineer, designing components and so forth, and assembling parts together. To be able to do print consolidated parts into one print file was a revelation, real revelation. Recently now I'm working for Desktop Metal. What we're actually doing in the energy sector, we're working with people like Saudi Aramco. We're now seeing a transformation taking place in the industry whereby decentralizing production. As the panel already mentioned, they want to have print in country. And we're actually seeing that transformation taking place with Total Energies in Angola. Being able to do that, obviously, is environmentally more sustainability friendly and so forth, reducing carbon emissions, etc., being able to print locally. I guess we also have the tier one suppliers. I mean, it's not just the energy providers and so forth, but the tier one suppliers are also embracing 3D printing to be optimizing their design shapes and so forth. 3D printing is enabling people to design for the function of the product rather than designing how can I manufacture the product. So we're now seeing more organic shapes taking place and better mechanical properties and production performance. From Desktop Metal's point of view, specifically in the energy sector, as I mentioned, we're working very closely with Saudi Aramco, producing parts in country. Spare parts is a key requirement for them. What we're able to do is now have that digital inventory, whether it be in the cloud. I'd certainly like to talk to you more about that in detail, Brede. But certainly locally, they have their own digital inventory and being able to print as and when required, print on demand. Therefore, when it comes down to the logistics, supply chains and so forth, the warehousing costs are drastically reduced. There's no overproduction. From a 3D printing point of view, additive manufacturing is a key word, additive. It is not subtractive. So therefore, when you machine a component, you're wasting material, a waste of swarf and so forth from CNC machining. With additive manufacturing, certainly with our processes, we're actually reusing the unused powder that's being produced to build the parts. So we're recycling the powder. It's more sustainable, more practical, and lowest part cost. From the end user customer perspective, traditionally in 3D printing, you need to buy the material from the OEM, the manufacturer, and that's been a high cost. From Desktop Metal's point of view, we have a different view of that. We do provide materials, but we're also open source. And that enables the end user to be able to source their own material supply chain, the feedstock and so forth, to be more cost effective in the environment. And you're not locked to a single source supplier. Within the industry, you cannot be locked to a single source supplier if you need to produce multiple components or highly critical components for that matter. You need to have that flexibility in the supply chain. Yeah, that's me in a nutshell.
Thank you very much, Paul. Thank you. Yes, from your point of view, what you can say about yourself and the additive manufacturing challenges?
Okay, so thank you very much, first of all, also for the invitation to be here. Thank you for the very interesting presentation so far. So my name is Jens Karnapp. I'm with EOS Additive Manufacturing for about 4.5 years. In the meantime, originally coming from the gas turbine industry, and yeah, this spark moment that we also heard before with me was basically when I saw that additive manufacturing, yeah, more and more infiltrated my back then industry, gas turbine industry, and I thought, okay, so from both perspectives, actually, both from gas turbines and from AM, this is one of the coolest fields to be there in this very moment. And I'm just as much and even more of this opinion after these 4.5 years, because we're living in a time right now which in my opinion is extremely interesting because it's not the testing status anymore, it's not trying out, it's not making prototypes, but it is really there. So additive manufacturing has proved that it can rise up to the challenge in many applications. In gas turbine applications, but also in different applications here. Angeline, I'm looking a little bit in your direction because we have a common partner, Baker Hughes, that you are building parts with, and we are supporting them from the machine builder side. So here we do have applications that are in use and that do their job. So when asking my biggest customer, which also was a couple of times mentioned here, big European gas turbine manufacturer, what his biggest goals would be and his challenges for us, it was not surprisingly increasing the productivity of the machines and having bigger build platforms in order to be able to do bigger builds. But on the very top of this wish list, the number one was something that made a deep impression onto myself, and that on the one hand shows that we are there, that it is working. But then we still have quite a way to go, because that wish was they want to have a boringly reliable machine. So they didn't want anything flashy. They didn't want something printed in magnesium. They didn't want to have something, they didn't want to have their cars printed. They just said they want to have a boringly reliable machine. And this is one of the main aspects actually that we're working on, and which is making a big part of our everyday engineering and customer interaction life, to make this wish come true. And very specifically in terms of digital inventory and distributed engineering, I can say we are already at a relatively decent stage in terms of repeatability and general process and product quality. What we're now working on here is really, on the one hand, making the distributed manufacturing a reality in terms of making it safe and really usable, all day usable. Yeah. Then on the other hand, make sure that you get the quality out of your network that you really require. So that obviously entails a bit more than just a handful of things. A lot of details on that one, but I'm very happy to answer any more detailed questions on that one later on, if you like.
Thank you. And now I'd like to hand over to Giancarlo. Please.
Buon pomeriggio, and thank you very much for the invitation. It's a great event, really vertical, that is also really necessary, in my opinion, for the additive manufacturing, being more and more vertical on the application. So, good afternoon, everyone. So, my name is Giancarlo Scianatico. I'm in robots since almost 1 year. I was previously leading the Italian market at US for roughly 5 years. So, I had also the opportunity already to have a quite wide experience on additive manufacturing, on technologies, and where we are moving on. Robots, briefly, it's a technology provider. So we are focusing on the high-performance polymers. So basically more, let's say, for the metal replacement, that is also a quite important topic also for the energy market. I'm a mechanical engineer. So coming back to the question, we have a huge responsibility. This is a very strong message that we had today, because all these ladies and gentlemen want really to change the supply chain, means change the business, means change completely the company. This is quite a big challenge, and we have to understand, that being a technology provider, that we have a huge responsibility on this. There are things that, in my opinion, we definitely need to improve altogether. The first thing is that the positive thing is all these 4 people said at the end of the speech the same thing. We need to work with you. Help us. That it's incredible in the industry. I was coming from other companies in the past as ArcelorMittal, Bosch, and it was quite unusual to see customers saying, hey, look, please, this is my hand, please help me to work together. That is an incredible opportunity for us and responsibility. So what do we have to do first? Listening, understanding what are your needs, understanding how we can pitch to your vision. That is not easy at all, because there are different challenges that, in my opinion, we have still to improve, everyone in the additive world. The first one, as was also mentioning my previous colleague Jens, is definitely that if you really want to delocalize completely the production worldwide, we need to have a reliable technology. We need to be repeatable and accurate. We have to be sure that every single part that is produced in Angola or is produced in Singapore is exactly the same. And this is not easy at all. And there are a lot of improvements that we have to do, but we are on the right side. The second thing, in my opinion, this is something that was partly mentioning, but it is also a big step, competencies. One of the reasons today, in my opinion, we are still not scaling as we could already do is a lack of competencies. We need to change the mindset of people that can engineer parts in another philosophy. And this is something that the only way we can do is by working together. This is another big responsibility that we have, because by being the technology provider, we can help a lot on this together with our partners to make the change. I believe that if we will fulfill properly the first topic, so the repeatability and the competencies, plus maybe sometimes being also some more productive, we will scale very, very well. This is the 2-3 points where we are working today in Robose. Robose is a scale up. We were born on 2015, but this is exactly the mentality we have and the vision we have for the future. That's it. Thank you.
Thank you. Thank you very much. Very good point, and I think it's
realistic as usual.
Thank you, Giancarlo. Now our next guest is Zach Walton, Technical Sales Manager from Velo3D. So also Velo3D is quite a new company. So how are you facing these challenges?
Yeah, exactly. So similar to Robose, we were started kind of around the same time. We focus on laser powder bed fusion and really the industrialization of laser powder bed fusion. So first I'll kind of give a little bit of my background. I've been at Velo for about 3 years. Before my current role, I worked for mainly in the industries like energy, turbo machinery, and a lot of that was because of my background. So I spent about 12 years between Halliburton and Caterpillar. A lot on the mechanical design, so a trained mechanical engineer, but through the end of my career at Halliburton, a lot in the supply chains. So not just doing R&D development of new product lines, but then how do you actually go implement supply chains in Saudi Arabia, in Canada, in the lower 48, and be able to actually scale that, which even with subtractive practices is not the easiest thing sometimes. So my introduction to metal 3D printing is when we first started looking at laser powder bed fusion at Halliburton. And then very soon after that, I was fortunate enough to join Velo3D, and like I said, ran those kind of industries until the current role I'm in now. Which, getting to your question of how do we help, one thing that was said about Robose is the education, the consulting. You know, making sure that people kind of understand what is capable, what's capable with newer technologies that might not be with older technologies, but just really how do you get to the end line? Because at the end of the day, people need to be able to make their components, they need them to be reliable, they need to be able to be repeatable, and they really need to have the confidence that they can use the technology and that it's not a myth, kind of like part of the title says on the top. And so the role I do now and the whole kind of technical commercial team that Velo3D has is 100% that. It's working on people's business cases, going into excruciating technical detail like what to expect for surface finish, for tolerance, making sure that you're not going to have that question mark when you go produce your first part or first set of parts, because that already leaves a sour taste in somebody's, in somebody's mouth. And I've been on the other side of the fence from being in the OEM world, and I've seen that happen multiple times. So that's one element. The other element is, we say the word standardization a lot. And I was part of the API 20S committee, just like a lot of folks in here. And we've also seen the D and VGL specs come out. And it's really awesome to see, the industry, a lot run by the gals and gentlemen up here. But the OEMs, or the technology providers, also have to do their part in the standardization. And if they don't, and the reason I say that is you can wind up with a standardization driven by the industry that is more expensive, more cumbersome, and can really limit the use of any technology, not just metal 3D printing, but any of them. And so one of the things that we do at Velo 3D, based on how our technology works, is obviously partnering with industries, with OEMs, but a lot of it around the standardization for the mechanical properties. So not just the reliability, can I get the same part on any of the printers, but how do I also make sure that I have allowables for mechanicals, because that is the basis of MMPDS for defense, for AMP or NACE, MRO 175. It's all based in, can you repeatably do this? And so working with industries, we have some fairly ambitious goals, and then how our technology works in general to be able to solve those challenges, which we think are extremely important to build a foundation that then allows not just, can you print a digital part now, but what do you do 2 years from now, 4 years from now, 5 years from now? Can you repeat that? Can you do it again? Which is the ultimate goal of a digital inventory, or else you kind of stay in the same place. So I think those are kind of two of the biggest things I see from our side of how we're helping and engaging. And just like I think the theme that's been from everybody so far is the collaboration is what's needed. It has to be OEMs, technology providers, and end users. And from my role now, where I get to see all the different industries, it's most exciting in energy because there is that collaboration, a lot more of that collaboration going on, which is exciting for the future.
Thank you, Zach. So collaboration seems the essential word, and have you seen here the 4 representatives from end users? They are collaborating now. And the question is up to you. Are you ready to collaborate with end user, OEM, and technology providers for the future? Who is ready? 1, 2, 3. Okay, we have to work better to improve a little bit the awareness. And so I'd like also to ask to my guest, do you have any question to the technology provider, to Steve as representative to OEM, how we can improve the collaboration? Maybe, Brede, you want to start?
Okay, first question to Robosa. I think you were honest and said this is difficult. This means you need to change your business model. I mentioned in my speech that we are trying to find a model that will make it possible for you to earn money on the digital content, and that is new. It's new for us to pay for a digital content in a digital inventory, but it will also be new for you. How is your prospect of actually trying to find a new business in the digital inventory, but then as a trade-off maybe reduce some of the physical sales? How will that work for you?
I think that the first important thing is, as you also were mentioning during the presentation, is that it's important now that the production is localized. So we have to print what we need, where we need, and how we need. To do so, we have to scale the technology. We can't do this alone because we are technology providers. So it's totally stupid to think that we can change the world by working alone and trying, to be everywhere in the world. What we can do is working also with strong partners. You were mentioning also in your 5 years vision that there will be also a lot of OEM, so a lot of, let's say, tier 1 OEM solution providers, so there are many names also to find also these categories, that they have to be really close where the need is. So what we are doing in Robos at the moment is that we are working on what we call a 3D parts partnership. We really want to have strong tier 1 OEM solution provider close to you, able to work properly with our technology and serving you exactly punctually. On the other side, I would say to work more on the digital mindset. I have to say that if you are looking also on our new technologies based on the Argo system, we have already introduced also a PLC inside the machine as well. So this gives you also the possibility to have a connected network that you can use also internally, so that you can be sure that if you have a file that is the real power in the future, you can share this everywhere also in the different printers. Did I answer to your question?
Part of it. So maybe I can elaborate a little bit. The technical side, I think, will be the most easy one, because as engineers, that's what we are used to, dealing with technical problems and solve them. But when it comes to the commercial side, I suspect it will be even harder. And that's also what I'm trying to get some reflections from all of you suppliers on how you can see that this can be a set of opportunities, but of course I guess you also see some risks. So how are your reflections around that transformation from a pure physical delivery to a combination of digital content and physical delivery?
I have to say that from my side, this is surely something that it will come in the next future. This is something that, in my opinion, has to be also defined case by case, industry per industry, finding the right solution. Today, for us, what is the real important target, was what I was mentioning before, is having a strong and robust technology first, and also support the market with competencies. Without these two things done properly, also talking about different business model based on the digital could become complicated, honestly. Thank you.
Thank you.
I could add to that a little bit too. Kind of very similar in terms of, when you said kind of like what type of workflow from the commercial technical side, I think one of the things is some of the compromises that sometimes have to be made. So I always take it back to creating a bill of material, right? If I can't have all the digital information, which is what additive is, it's a digital technology, in that locked bill of material, that A, makes it harder to, again, print it sometime in the future, but it just makes it makes you have to start thinking of a different way to set up a digital part, way to set up a manufacturing process. And then I think kind of to the digital content side of it, I know one thing that we've worked on with the way our solution works is you get an encrypted print file. And so there's nothing to say in the roadmap of the future, and working with industry partners, if there needed to be a limit on the number of times that that's printed, or that IP need to be controlled at the either OEM or end user level, it's easily doable with future kind of software evolution versus full kind of hardware or complete new manufacturing process evolution. So I think there's a lot of technologies coming online that I think it could start staying a little bit more like traditional kind of rollout of supply chains and manufacturing. But the IP, the number of times you can print a part, those type of things, I think still have to be kind of an industry discussion, and kind of, I think Carlo said it best, some amount of rules, or it's kind of everybody sitting at a table defining what those rules actually are. And then I think it's fairly easy on some of the newer technologies coming out to be able to implement those.
Thank you. Please.
May I ask a quick question to the community here, because okay, the commercial models obviously is one thing. I also do think a little like my ex-colleague Giancarlo, that this has to evolve. I think we are in this very moment at a stage where we have the first technologies that work fairly well. So we have also seen there's blockchain technologies, digital printing rights servers hosted by different companies within different group constellations. And from what I understand, from a technical side, this works fairly well. So also EOS, for example, has done collaboration with Boeing, for example, and Assembrix to do an implementation for this kind of digital rights management, which worked fairly good, I would say. The question that I'm asking myself personally is, in how far is the situation with the digital print files so very different from the conventional manufacturing, because also there you have NDAs, You have a very sensitive IP in terms of drawings, in terms of recipes, and so on and so forth that you pass on. So my question would be, can you explain a little bit to better understand what your fears on that side are? Is it that it's more easily copied, that it's a plug and play, I push the print button thing that makes it easier to copy things? Or on the other hand, what does it make it so much more infringible than the classical way? Or is it potentially that the idea that somebody says, okay, now that we have it all digital, then let's use this opportunity to make it safer than it was before?
I can answer that. Traditional manufacturing is different than additive. It's more fragmented. What you're doing with additive is combining different manufacturing steps in one. Okay, so if you think about castings and forgings, you start from the piece of forging and casting, then you do heat treatment, then you do machining, then you do even more machining, cladding, machining again, and many times that is carried out by different suppliers. So there is not really a secret recipe that stays in one place. Okay, so the information itself is definitely less secure than a digital file, because many times traditional manufacturing is still using drawings. I mean, if you go to any machine shop, you will find detailed drawings from many OEMs, but that is one piece of the information, and normally it's fragmented. Additive is combining, and by combining, making it potentially more dangerous, because everything is in one place. The other thing is a redefinition of the IP. Okay, so as of today, if I want to make this shape, I just need to send a drawing to a forge master and then a machine shop with dimensions and tolerances, and they do it. If I want to 3D print the same object, the dimensional part is one portion of the IP, and then you have all the printing parameters, that is a second portion of the IP. And in my experience today, there is not a clear definition about who owns the print portion of the IP. Is the technology provider, is the service bureau that is printing, is the OEM, is the end user, is everybody? I don't know. And that is neglected. By neglecting that, we are exposing to a risk the entire process.
Yeah, okay, thank you very much. Regarding the recipes, so the print parameter files and setups, I think from a technical side this can be very clearly defined, who is the owner of that. And there is definitely mechanics and processes how to do that, and we're doing this already. The question might then be, okay, how is it generally adopted as an approach within the industry of who owns that?
There is not a single way, because we don't know what we don't know. And in my experience, everybody is sort of new when it comes to definition of this type of IP. Many times it happens that the OEM, the equipment OEM, the valve OEM, for example, they strongly want to keep it because they, at the end of the day, they own the overall IP. In other cases, I experienced end users or operators like ourselves that we want to own it for no real reason rather than having some sort of control. But in many cases, the technology provider like yourself is the one generating it and keeping it. And that is creating confusion. Again, I don't have the answer today, but I believe that the overall initiative about the digital warehouse has to tackle and define also that aspect.
Just one very last word to that, sorry. So thank you for pointing that out again, because this is really something that we experience, that the customers, especially our big industrial customers ask us, they want to have an open parameter set, they want to be able to modify it, and they want to be able to keep that and make it theirs. Which I need to admit, the process of understanding that at the beginning was a bit slow. It picked up considerably speed in the last couple of years because it was repeated from many sides. And what I see in the meantime is that at least for the big OEM customers that we have, they build on our templates, so to say, on our data templates. They develop the parameters further for themselves. And we provide them in the meantime then also with containers, so to say, how to really make these parameters theirs that they do not need to share with anybody anymore.
I was just going to add to that, you know, the machine parameters are accessible. The OEM doesn't lock them down. The end user can actually have access to all the machine parameters, each layer and so forth is photographed, so you have the traceability and documentation. The question is, from my point of view, who do you want to own that IP? Is it the guys that actually design the component? Or is it the guys that want to just manufacture or produce the part?
Again, I don't have an answer today, but I believe that goes together with the commercial considerations. And it has to be something that will be sustainable, and we will make not only the operator happy. I don't care about being happy. I care about the OEMs being able to use the technology and delivering what I need when I need it.
So the end user would have all the repeatability and all the documentation for each part build.
Traceability is a big thing for us, and has always been like that. It will always be like that. I believe that additive is actually going to improve traceability big time on materials, just because by design we are collecting, the technology is collecting a huge amount of data. That is another topic, because too much data is not always a good thing, but that is a good starting point.
Okay. What I find interesting is to look into the future, bearing in mind the network structure that we are talking about here. Of course, you have a physical delivery at the end of the network, but you also have many different competencies and also IP rights for different part of the process. So I think we will see new service providers and new business areas and ways of actually earning money on the know-how. Maybe the parameters could be something that when you developed a parameter for a certain feedstock, certain material, that's something you can sell instead of the factory in Rio has to do all the development themselves. They can actually purchase that as a service or as a solution from the network. So we have to look into that. There will be new business opportunities, and we see new service providers that are purely digital in this new network. And that makes it very interesting to see how this is going to evolve, because we don't have all the answers.
But I mean, coming back what I was saying before, listening, it's the most important thing. So today, in this moment, we were talking about a topic that had a different vision, different understanding, and different things. So these are things, for example, that you have to develop accordingly your needs and how to manage the supply chain, again.
I'm going to build off of his point for a minute there, because I think you raised a good point. So energy facilities don't operate the same year after year. They change. So with the technology, you can adapt each year, each season as the field matures. So that's going to require hopefully the OEM, hopefully someone like me, to still have a job and design a new part, new solution, and then print a new technology. And then you could then transfer that. And there must be a way to share this file somehow. If we can share music by online, and we can, move work to different factories around the world, there must be a financial, economic way to do this. Thanks.
I have a question. So I'm sure, and the energy sector is expressing a strong desire to move towards on-demand spare part printing closer to the end user. This really requires a substantial development in terms of availability of capacity to meet that need. And I was quite curious to hear, how do you see the demand for you in machine making, whether it's EOS, Velo, Robust, supporting that growth agenda coming forward? Because it's not just the energy sector. Because of the supply chain challenges, that same need is also being felt by other industry sectors. So the growth is there. How are you able to meet it? The second question is, within your own machine, how much of the spare part for maintaining your machine today are in digital format?
That's a great question. I can speak from Desktop Metal. We have many 3D printed components that are part of the printer that we sell, and also including spare parts, and we're proud of that. And we want to go as much as possible in that field. Even looking at sheet metal components, tooling for sheet metal is now 3D printed. And we're also very active in the polymer business as well. So, but yeah, it's a great point. Practice what we preach. That's my message there.
Maybe answering your first question regarding the capacity. So do I understand your question right in terms of how do we try to support that enough installed capacity for operating a network like this exists? Okay. So on the one hand, as I said before, there's these more technical approaches regarding the printing rights and a distributed platform that we push forward with different partners. On the other hand, also both to lend capacity to distributed manufacturing, but also on the other hand giving capacities for companies that are new to additive manufacturing and do not immediately want to invest into a machine. There is a network that the EOS is building up together with partner companies, the so-called end-to-end production network with certified production partners that have our machines and other machines. So it's not a completely EOS thing, but it's a real world setup, so to say. Certifying these partners so that we can when we are asked to lend a hand in order to allocate capacity to feed that through the network. So that would be the economical and company partnering approach apart from the technical approach. And then the second question, in terms of parts and spare parts additively manufactured in the EOS machines, there's many. You see them immediately if you open an EOS machine. There's a lot of components in there that will be very expensive to machine, but can be printed with that technology in a very nice and a very efficient way. I have no percentage, unfortunately. Sorry for that. That would have been a cool number, but it's many.
Thank you. From Robert?
Yeah, second question, absolutely yes. We have also because, as you can imagine, we are also facing issues with the supply chains on getting parts. So we are more and more adopting also using our technology for parts. Definitely, we have to give the example. Otherwise, makes no sense to discuss in events. The first thing, so coming back, yes, partners. There is one only way to scale the technology and to support the end customers, having right partners. Because there is not only a question of language, that is also important by talking the same language. There is a question of mindset language, so the partners understand perfectly what is the customer need because they are usual to work with. And there is also a third point that is very important in the regulated companies, as for example the energy and also the aerospace. We need to have people that have the right certification to produce parts, otherwise they can't. So to me, this is absolutely the right strategy to have a reliable scaling, I would say, adoption of our technology. This is mandatory, in my opinion. Because we have to focus what is our daily business. And our daily business is to make technology. And that's it.
And so kind of adding that a little bit as well, same, what's that? Sorry. The same approach, right? So a network of contract manufacturers is what we've deployed kind of over the last 2 or 3 years. And we're very specific to call them contract manufacturers and not service bureaus. And the reason for that is we focus on folks that are in industries like energy, aviation, space, defense, but have made their living producing good end parts. And then introducing additive technology, specifically kind of our system and our workflow, has proven very valuable because that's now the addition to what they've already done really well, working on machining from wrought or castings or forgings. The other element that we've also seen to the capacity question, though, is making sure that that network is growing at a healthy rate to meet the end user and OEM demand. We have a specific team on our commercial technical team, and Steve can attest to this, that works with the OEMs and end users very, very intimately, not just on the consulting and understanding, how to move a project forward, but understanding the forecasting. And again, a lot of my themes have been kind of thinking into the future. It's not what are you going to print, on this first project or next quarter. It's what does production look like for this, for other applications. And then because we have that close relationship with the network, we're able to scale it fairly efficiently. And then in terms of printing parts, I think the answer was yes for everybody, but we definitely, when I started at Velo, was right before COVID. We started development and kicked off our large format system probably in the heart of the COVID pandemic. So we had to get very resourceful for our spare parts and supply chain. So there are quite a few parts printed on our system as well.
Got a couple follow-up questions. Number one, you all have 3D printed parts in your machines. Do you make those drawings available for the machine buyers so that they can print those parts on demand, as we've been talking about today? And in your dealings with other industries than energy, are any of them ahead of us in terms of building digital inventories? And do you see opportunities for synergies with some of them in particular, where we could, combine our parts into a machine and reduce the cost, let's say? And where are you at, sorry, that's the third question, in terms of that, let's say, almost real-time capacity optimization. Hey, if you print this impeller in 2 weeks, you can make it fit with someone else's part and reduce the cost. How far out into the future is that?
I can take that one first. What was the first question? I've got the last two.
First one was, can I, if I buy a Velo system, print any of the parts myself?
I'd have to get an answer for that. I don't know. I mean, possibly. It's an interesting question. But yeah, I don't see why that would be a problem. I think the hope would be you'd be using your printer for other things, though. So we would be supplying those spares. In terms of, sorry, what was the second?
It was, are any other industries that you work with ahead of us in terms of DI and any synergies between them and us?
So Carlo's probably going to hit me, but we work a lot in the space industry, being kind of a newer 3D printing company. And so a lot of what I've seen them do with the digital supply chain is actually already be implementing that, at least on our systems that we see in the United States. And what it's allowed them to do because of the consistency is I think where they might be a little bit ahead is how they qualify the process. They don't necessarily, they qualify the vendor, they qualify the machine, but they don't necessarily do kind of an expensive qualification on each individual machine serial number, and instead have been able to scale their kind of machine or process qualification and part qualification together to where they can get new designs kind of qualified a lot quicker. And so I definitely think there's some synergies there. I think the API 20S and DNVGL was the starting point. And I think as the technologies continue to mature, as new technologies come out that simplify a lot of the conversations that we're having, I think that's where some of those synergies and learnings can come from is how do you get kind of quality parts and go through these qualifications with a less burden on cost and potential lead time as well.
Can I say something? Because we are working together on many of these aspects, so it's not a secret. And that is a conversation we had many, many times. The problem is we're talking about collaboration within our industry. This is cross-industry collaboration. These aerospace customers, that they can do this type of more efficient qualifications, they produce data. I ask many times to share the data. Until they will not be sharing the data, it's just his word. I mean, I like Zach, but his word has the same value of my word. I need data, because those data can be shared with the API committee, they can be shared with the industry committees, and we can change industry standards based on data. But again, we need to trust each other much more and work in a more collaborative environment.
Yeah, so the first question is yes. I'm not kidding, because with our 3D Parts partnership, we are also sharing projects. As I was mentioning, we collect a lot of requests worldwide, and then it's important also for us to share these projects with the right partners in terms of, as I was mentioning, geographically presence, industry, certification, and so on. So between these things, there is also the possibility really to print parts for us. It's absolutely not a problem. Again, I agree with this gentleman. I think that there could be very interesting synergies in the aerospace, especially for the spare parts, repairs. I mean, this is the approach. Again, the problem is the data. So I think that it's an excellent idea, but there should be a kind of, I don't know, association, entity, whatever, that understand that by working together, you can really speed up also this, because you have the same concern. So I strongly recommend, if it's possible, and if we can help somehow, because at the end we are talking also to these companies to do so. This can be really a very good opportunity to speed up, in my opinion. Thank you.
Thank you. From EOS point of view?
Yes. Short answer to the first question. We do, as of today, we do not have that as a standard process to print the spare parts for our customers. And now comes the but. We are with a couple of them indeed in discussions on doing that. And the point of the discussion where we are at now is basically the final quality inspection, because we can provide the build files, and many times there's also no real IP on them. It's simple pieces. Yeah. Then the customers are highly qualified, they're highly skilled, they know what they're doing, they have a whole machine park, they have a lot of experience, in many cases for particular applications more experience than we do, and so they're definitely able. It's at the end, it's a question to say, okay, so if something goes wrong because of that piece, yeah. But also then, I mean, once you are at a certain level with the customer, you can say, okay, we make a short note where we say, okay, so if you print that up to a certain degree is on your own risk, and if you're willing to take this, it's perfectly fine, and here you can have it. So this is with one of my customers. Again, also, we've seen them also here. We are in this very talk, and it's exciting. It's we have not really done it yet, because then at the end it was easier that we supplied it. But we are exactly in that discussion, on the forefront of that discussion. Yeah. That was question number one. Question number two: other industries that are further ahead. Now, I'm mainly involved in the energy sector, so I make a little bit of a parenthesis to this answer. But from what I see outside, is there is something in aerospace, there is something in automotive. I don't see any big leaps or a high gap or a high distance to the energy sector. It's yeah. The one is a little bit further, the other one not as far, but there's no categories between them, from what I see. And sorry, what was the third question?
Just any synergies where we use the same materials, we could print our parts together, or learn from their qualification practices, anything like that.
Okay. Yeah, also there, at least learning from the qualification practices, because also there, together with the big OEM industry customers, also we learn a lot on what is important in terms of process quality, material quality, repeatability, Yeah, what kind of things are okay if you see them in a cut-up, and what is not, and how does that relate to the product that then at the end is built. And so we do learn a lot with that one, and so different colleagues are also in different gremiums to define the norms that are putting forward the processes, so the AMS 7003 and the ASTM material norms and so on and so forth. So yeah, definitely a lot of learnings from that side, from our customers as well, and not only in the material aspect, but in everything else as well. So yeah, listening to the customer, and this is not just said like this, but listening to the customer is the most fun for me aspect, and yeah, maybe also one of the most important. But it is fun. It is really fun because it makes you better understand what you're working for, and this is something that I really appreciate with EOS and my customers.
Thank you, Jens. Paul, any thoughts from your side?
Yeah, I'm just thinking when we talk about printing spare parts, trying to identify what spare parts we could provide as 3D printed is proving to be difficult for me at the moment, mainly because the failures are typically servo motors or printed circuit boards. It's not actually mechanical printed parts as such. And if it is, it's part of an assembly and it's got some wiring in there and so forth. But certainly the housing and so could be provided if that was needed. Sharing industry standards, all I could probably say on that would be the ASTM organisation of additive manufacturing, if they're sharing their certification programs. I'm not sure. I would have thought they would be open to that. And I've forgotten the second question. Sorry.
It's all good. I think we can move.
Okay, thank you. Now I'd like to ask to the audience if there is any question. Do you want to ask something to our operators, OEM or technology provider? Any curiosity, any doubts, any challenges that you face and you want to have maybe a reply or a thought from them? Maurizio is the president of Valve Campus Association, who is hosting us in this beautiful place.
Yes. Once again, congratulations to all the members of the roundtable. It was very interesting. I heard a number of times the terms spare parts. I see the additive manufacturing and the digital inventory tremendous opportunities for the industry. However, there is a big risk. You're going to lose hundreds of potential suppliers as soon as they understand that by supplying through the digital inventory their know-how, their drawings for spare parts, they will lose part of their business. And this is more critical whenever you hear, and we heard that the manufacturing of spare parts through the additive manufacturing can be done far away from the engineering center where the product was developed. Spare parts is not just a casting. Spare parts are components vital for the reliability of valves, reliability of the plant. I'm thinking about internal trims, and I don't know if Carlo agrees on that, but the risk is that they will create a lobby of few manufacturers that will accept to have their knowledge being transferred far away from their production or engineering centers. So this is something that you have to take care.
Oh, absolutely, you're right. I mean, I do agree that that can be the perception. I can assure that this is not the intention at all, and probably that knowledge, that IP, it will stay with the OEM. It doesn't have to be physically transferred anywhere. It's just the manufacturing process itself that it will be delocalized. But I do agree that that is the first impression and perception of what can be a risk of a digital inventory. That is not the intention, at least, of the initiative that we are starting together.
And I think that, if I can also, it's important that today we are here just for this, to explain that also for people that maybe is the first time that are understanding what additive manufacturing is, understand that there is a change, and maybe they have to take the opportunity also to change their vision and to change the business model. There is something that sometimes when I make some speech about Industry 4.0, because at the end additive manufacturing it's a part of the Industry 4.0, and I learned many definitions of Industry 4.0. At the end what I said is that it's just a new business model. And sometimes I say, if you get married with this business model, you will go on. If you will not, maybe you will have some trouble in the future. So it's important to understand that there is an opportunity. There are things that are starting right now, the vision. So important is to understand this change and eventually to catch it for the future.
If I may too, most of my engineers are younger than me, and they're used to working all in CAD and working remotely, especially after the pandemic. They're used to being on Teams and Zoom calls. So for them, this idea of making it all electronic and sending it digitally, for them it seems very natural. So the next generation, I think, will make this change. It's inevitable it's going to come like this. Thanks.
Thank you. Thank you, Steve. We have, I think, a few minutes for other question. Riccardo?
Yes, hello.
Please.
I am Riccardo Girelli from Laborment 2 of Turin. We are a service providing of CT scan technology. What do you think about the use of the CT scan for the digital inventory, for an accurate reverse engineering of the components?
Who want to, Brede, you want to reply? Or is more technical? We leave...
I can give you my 2 cents on that one. 3D scanning has been around for many years, and the reverse engineering has already taken place. I can assure you of that. How you protect against it, I'm not sure. It's like music, it's copyright and so forth.
Okay, from a technical perspective, it's not all about dimensions. And okay, first of all, we have to be careful when we use the word reverse engineering. Again, we are not in the business of saving money by making parts on our own. I don't do that. ConocoPhillips doesn't do that. In case, very specific cases of need can be done, where there is no real OEM associated to a non-critical part. But again, 3D scanning, and correct me if I'm wrong, gives me dimensions, right? What about material properties, tolerances, all these aspects? Again, if I am not the OEM, can be dangerous just to rely on overall dimensions without all the other data that you need to have a reliable component.
Steve, you want to do?
And back.
Okay, we have another question, please.
Yeah, thank you so much. My name is Niels. I have a question because, well, actually, I have a kind of a shout out to the AM Tech people here, the four on the site. So what Brede actually showed on the screen with a digital supply chain, basically, that's a whole network. We've built that for aviation and for automotive. And the one thing that you need to have is a collaboration between the OEMs, the end users, but also software providers and the hardware providers. And the showstopper is always IP protection. There's not one single OEM in these industries that will actually allow for their stuff to be sent to wherever if you cannot safeguard their IP. Also, what Angeline said about digital passport, that requires a two-way communication into the hardware. So we have been trying to really hard to find 3D print manufacturers that allow a network like this to actually send encrypted print files directly into printers and give feedback for this. And this is something that does not land quickly or at all with the 3D tech companies, that they actually have to make their hardware software-wise so good and open that you can do this. So it's oftentimes a hardware company first and a software company second. There are a few exceptions. Jens works for one of those. HP is actually doing this kind of stuff. But I think it's critical for the hardware providers to realize that the IP safeguards and the license management, that you don't print more than you actually pay for, are critical for the OEMs to actually join any endeavor like that.
Thank you. Thank you very much also for your speech. And is there any other? We have here two more. Okay, I think we can take the last two. Thank you. Yes, yes, because we are quite late. You want to leave? Okay. So we just have to say thank you very much, Angeline, for your time. We know. Yes, you are in a hurry, so have a nice trip back. Thank you, thank you, thank you, Angeline. Goodbye. So please.
Hello. Okay. Yes, my name is Fabian Hesse. I'm from a trading company of Switzerland. Very interesting topic. I have never. That's the first time I listened to this this new technology and what is possible. And obviously, also somewhere along the chain, the supply chain, all these drivers, courier services, logistic partners, like a sales company, intermediate somewhere. But what is sure is nothing is as certain as change. I mean, there is nothing we can do about it, and that's maybe the new mindset that also has to come with everybody. Everybody was afraid of the 4.0 industry when we talked about it. Some people were afraid that they lose their income, but I'm certain there will be other ways generate income. My question is about more material. You know, material from a material perspective, you have cast material and forging materials. A05 for cast steel or 10619 for cast material. Is the material that you use for 3D printing, will there be a new specification, or is it the same kind of material code? How do you define that? Because it is not forged and it is not casted.
Essentially, it's the same material form, ASTM type specifications. What's evolving still is the specification for things like API and NACE requirements. But there's an ASTM F3055, which is the specification for most grades. And typically, we're looking at higher alloy materials too, with the steel printing.
Okay.
So with the same mechanical properties, basically, as you would assume?
Mostly. The bulk mechanical properties are the same. It's when you get down to the, I'll call the grain level, that it gets interesting and different and requires more nuance and review.
Thank you. Thank you, Steve. So last question, please.
I suppose it works. Yes. Hi, Valeria. Hello, everyone. This is Giulio from Erlikon. And thank you for the great discussion. It's really straight to the point and interesting. So my question was to the panel, maybe, to Brede, Edwige, and Angeline is not there.
Carlo.
Of course. Maybe he will answer. I know already he might answer. This is quite technical. So we all know that this is a challenge. This is a great vision, but in additive world there is variability. So aside from the drawing, aside from the step file, we have a process from powder to post-processing. How are you managing this machine-to-machine variability in the process? So are you already accounting this into your digital IPR or not? So just a generic question, because I think this will make a difference as well. Thank you. Thank you very much.
Okay. Actually, there are several different answers to your question. First of all, just to take a little detour first. Many people ask about, what about guarantee? Would the guarantee lie with the OEM or the factory? But today it's okay, very clearly at the OEM, and those who produce it then answer to the OEM. But having this distribution of production sites, then you have to accept that the guarantee is split between those who have done the design. And if you find something wrong in the design, of course, the guarantee lies with those IP owners. But if there is a mechanical error that came with the production, then, of course, the guarantee will lie with the factory. So we see that there will be a lot of different new ways of looking into these different aspects that we need to solve. Guarantee is one thing, IP was mentioned as another one, and it won't work if we can't protect the IP of those who have created some work. So we have several different solutions that we have looked into. We have already started using blockchain technology to lock the ownership to the digital content so that nobody can go in and try to steal or tamper with your file. So that means for us it's not just the ownership, but also that nobody can go in and do damage to your digital file, and therefore when you print something you have something that is potentially dangerous. So we are looking into this in many different aspects, and the only way we can find solutions, and at the moment we don't have all the answers. So we need to work together with suppliers, with a set of end users to ensure that we find solutions to all these different questions. So I didn't answer directly to your question, but still in the ballpark. You want to fill in?
Just to be sure, was it really about the variability from one printer to another, one supplier to another?
Yes, of course. If you have a drawing and a process stored somewhere, that is different if you print in this machine or in a place or in another, or if you use another machine. So there is power, machine, and process. But of course, to be answered, we have to work collaboratively as an ecosystem to overcome these, let's say, variability on these variables, and find a way to share and manage this in the design of the It's kind of answer.
Maybe just very quick annotation. I mean, there's also there is standards for the additive manufacturing industry, and for very specific metal materials as well. So there's something like for titanium, for example, there's an ASTM norm F3001, I think, which exactly specifies so what should be the minimum material properties that need to be reached. And question also to your side, I mean, are you basing your drawings and the requirements on your drawings on norms and standards like these ones, for example?
Yes, definitely. So the existing rules and regulations are still the same. So we need to find ways to prove that the quality is according to the standards. And also back to your question, we need to, for instance, have certification of the factory. That means you have to have the right machines so that they are qualified, tested, and we know that they are in the right environment, no matter where they are. And then you have to test and say that your processes are ensuring the right quality. So I see a distribution of certified factories. But then you have the feedstock, and then you have to ensure that you have a certificate on your feedstock, and maybe there are different specifications to different feedstocks. So there's a large amount of work we need to do to find all those different specifications needed to ensure that the end product has the right quality and is repeatable.
Thank you, Brede. So we are coming to the end, but we have the last topic, just to help you to reply to this question. So it will be a dreams or reality, the use of additive manufacturing and digital inventory. So I have a question for my guest. How much the sustainability will play a role in the adoption of additive manufacturing and digital inventory? So maybe, Carlo, please, can you start?
What is your definition of sustainability? I'm serious. What is the definition of sustainability?
I know that, big energy companies are working for zero emission, decarbonization.
And that is an incorrect definition of sustainability. Sustainability, that is one component. Is the economical component and the environmental impact component together. So yes, the answer is yes, it is important, but they are not disconnected. is not all about making something greener. It has to be sustainable from an economic perspective and from an environmental impact perspective.
Okay.
Yes.
Thank you. Edwige, from your point of view?
And I'm sorry, I'm going to hijack this opportunity to ask one last question to the technical service providers and OEM here. So we need to quantify the difference in Scope 3 CO2 emissions that we can have if we print a part instead of casting or forging it. So, number one, so what are you guys doing to prepare for that? Are you able today to quantify the CO2 emissions for a part that we order from you guys? And then we need to compare that to the old way of making things. How do we do that? Maybe the casters and forgers won't be will be a bit reluctant to share that data. So how do we fix this?
Okay. 31% of the CO2 emission in the world comes from manufacturing. That means we can make a huge impact on the global CO2 emissions by being smart in our industry. So I would rephrase the question, the environmental friendliness. How can we impact reduction of CO2 emissions? Yes, we can, to a great extent. And the other area is we can remove a lot of waste, and that is physical waste. And as we have seen through the presentations today, we need to reduce CO2 emissions, but we also now see a lack of raw materials in some areas, and in the future that problem will increase. So by reducing the waste of physical products, then that will be a benefit for our industry as well. So I think the environmental side is extremely important for us, and as formerly oil and gas company, now energy company, we have a lot of focus on that we are part of the problem here. So we need to demonstrate that we can be part of the solution. So we have a very high ambition and very high dedication to trying to find ways where we can solve some of the main environmental problems that we have, and maybe that can be transported to other industries as well, not just the energy.
Thank you, Brede. Any more contributions?
Quick question on whether will it be sustainable or not. So there has been a white paper together with one of our industrial customers really comparing one-on-one, producing more or less the same part conventionally and additively. And there's an incredible amount of factors going in there. So it's really, it's fairly close to one another. And secondly, it's very hard to assess really to the last detail. On the other hand, what is absolutely clear is if you have an application that you can only do additively, for example, you repair a part that conventionally cannot be repaired, and there's a couple of them out there, the effect is completely crystal clear. There's not a single doubt on that one. And then lastly, I think you said it before. You have a warehouse, or you have a stock of 3 billion, if I remember correctly, and 30% of these do never see service before they get scrapped. So if we avoid that one, how much greener can it be?
One thing is sure, I mean, on this topic, accordingly our experience, we were discussing many times also in the past, there are still a lot of industries and companies that did not really understand concretely, in terms of figures, what could be the impact by using this technology also on the sustainability, in terms of economical point of view, as Carlo was mentioning, and also in terms of environment. So I think that the approach is still not the right one, because we are always comparing what we do with the conventional technology on what we do with additive. But we forget all the, let's say, complete workflow, what was mentioning before also Angeline, that at the end of the day, it's a huge saving. So again, it's really important that companies start thinking also in another way, to get the real value or the benefit of this technology, as you're doing, by the way.
Thank you, Giancarlo. Paul, your last thought?
My last thoughts on that one? Sustainability, absolutely. Additive manufacturing is making a huge impact on sustainability and environment. How much energy is required to keep a warehouse operational? How much energy is required to transportation of parts around the world? Just 2. If you take CNC machining, how much material is scrap, waste? You know, it's a huge impact. And the bottom line is it's not for me, it's for my children. That's where the big impact's coming. We talk about sustainability, it's also about, you know, about the next generation. What kind of world we're going to leave with them, you know? We talk about spare parts being scrapped. You know, there's a great initiative taking place with, I've forgotten the name of the company in Italy, but, you know, to take the scrap metal and recycle that into powder. It's already been done in the foundries for casting. You know, they take the spare parts, melt them down, take off the waste dross material into the ingot, put it into an atomizer, produce the powder. You know, recycling.
Thank you. Zach, any thoughts about sustainability?
Is it on? Yep. No, I mean, we're all fairly in strong agreement. I think in practicality, we have to make sure of it. So Brede showed the closed loop, and like you were talking about taking spare parts, but I mean, like API 20S, DNVGL, a lot of the times, higher criticalities, you know, that first build is kind of sacrificial. You're going to tear it apart. You're going to do stuff with it. Making sure that those parts are also recycled in and just kind of having that full closed loop, I think, is key beyond the kind of the no-brainers like the shipping part of it, or like you were saying, just the 30% across the bottom line that's already cut apart.
Thank you. So Steve, you are the representative of valve manufacturers, so we are in the middle of the industry. What you can suggest to the other to adopt additive manufacturing and to start to think about digital inventory?
Well, that's a lot. I'll try my best.
Yes.
So again, what we did is we looked at where we built parts that were complex, had lots of internal features, and recognized an opportunity. And what we discovered along the way is not only did it make the parts better, but it also reduced the process time. It reduced a lot of wasted manpower. So I would first off encourage you when you start this journey is to, when you pick a candidate part, is ask yourself, how is that part really used? What's the real risk involved in the part? What's the factors that you normally to think about? And think very much in a very large way about how you can transform the part with additive technology. Because I think you'll find enormous benefits that you haven't maybe imagined yet. And then the second question, I'm sorry.
No, that was just one.
That was it? That was good?
Thank you,
Oh,
perfect.
thank you. Perfect.
Very good example. Thank you. Thank you very much. So we are coming to the end. And first of all, I want to say that today we are making the history of the adoption of additive manufacturing and digital inventory in the energy sectors. We have the question, but now I'd like to ask you, what are you doing to allow, to support the implementation of additive manufacturing and digital inventory in the energy sector? Have you seen this person, these leaders are really convinced that this will be the future? So what about you? What are you doing? What you can do for the future of energy sector? So this is for you, and now I'd like to thank you, everybody. First of all, our speakers. Thank you very much for this fruitful discussion. And thank you to you, to the audience, and to Valve Campus for hosting us. Thank you very much, and see you next year, in 2 years. In 2 years.
Thank you, Valeria.
Thank you, Valeria.